can we put these back in the rows?
You just like me in the front.
Yeah. It's kind of random.
So you can make fun of my voice when you record me. It works. Oh, it's done. What are you doing?
You can get those chairs back.
We have these for a reason, though.
No, back in the rows, you just said.
I was kidding. I didn't say it.
Actually, I'm going to use this kind
How
of.
did you do it all?
Let's go.
No, we actually have to come back to roads. Right?
I'm not kidding.
I was enjoying the old pods.
There's 2 Jackie Minors. I just not in this class.
No, you're one of them. What is this?
Ward. Ward. We're not pods.
I moved from there.
Jackie, which Jack from there?
Oh.
There. Is that it? I didn't know it was back in the head more.
Okay.
Why are we all like?
Much?
Yeah.
I like it. Bonding? Before we graduate?
I guess there's 2 Jackies.
Jack's not here.
One of them we forgot to put me in for Jackie.
That's embarrassing. Maybe you should have
Yeah,
Maybe
you
he
just get a
doesn't want
picture.
you here.
I might have a fan ass.
Oh goodness.
What? What?
I gotta leave at 10:10.
Join, you want to join? Come here.
I have to go to the doctor.
Watch this. Watch how hard.
Would you rather me stay? I'd have to go to the doctor to find out if I'm ill.
I seriously forget the game.
Mom,
Oh, it is.
Yeah.
He's coming up with 72.
I was like,
Look how hard you're also missing.
That's why I'm seriously
Except for the bucket bag.
Okay.
Ward? I didn't think at 10:10.
dilemma.
I don't know.
Oh, yeah, I do.
I don't know.
Otherwise, I say this class and I say,
What?
I bring it back to Wednesday, you know, get your little child sick. You know what? I'm fucking mad. I like I said,
Okay, hey, all we're going to do today, take a few notes. I'm going to use some time to work on your assignment because I know we have an assignment due tomorrow. Just make sure of that. Pretty straightforward. Alright, so here's what I want to talk about today. We're on section 1.2 today. We have just a couple different topics that I want to discuss. So pretty easy. What we're based on here is functions. That's what we're based on. Notice I didn't say linear equations or anything like that. We're based on just functions. So there's a couple different topics that I want to discuss. Number one, I want to discuss the different types of relations. Okay, like basically how do you display data? That's what this section's all about. Like what we did in the last section, we talked about how to graph, how coordinates work. We're going to look at how they all kind of fit together. So that's our number one thing. Then what we're going to discuss after that, we're going to discuss there is a test for functionality. I don't know the word, but I'm making it. So functionality. So we have a couple different tests. There's one that's very clear, very easy. The other ones are just kind of like common sense kind of things. That's what we're going to look at after we get done with this relations. Then the last thing we're going to discuss is domain and range. And that goes really nicely with the relation ideas, so domain and range. And what we're going to be discussing with domain and range is we're going to talk about intervals. This is like the first day we intro intervals. So that's going to be our main goal here today. Interval notation. And this is the thing I've kind of hinted at from the very first kind of sections when we were doing prereq stuff. And I've said that, we're definitely gonna take a look at intervals at some point. Well, this is the day we do the first day. Okay. After we're done with this is just real quick kind of stuff. I'm gonna give you some time to work on that assignment if you haven't got it done yet. So some people do take some time to do it. To do that assignment, if you were not here, you need graph paper. Does anyone need that graph paper? No? Okay, good. So everyone got some. I will put always, like, on days when we have, like, homework like that where we get graphs, I will always put, like, an extra grid paper on my website. It'll just say, like, grid paper or Cartesian coordinate graphs. And when you click it, it'll download to your Chromebook or it'll just open up with Google Drive and you can save it and print it whatever you want. Does that make sense? I want to at least give you an option if you need more information. Okay. But let's just kind of jump into this. We have a couple different things I want to discuss. Really easy stuff today. We're keeping it real basic today. We'll go more in depth tomorrow. Let's talk about the relations. Okay, there's different types of relations for math. If you don't know what a relation is, it's a way of displaying data. That's the best way I can describe it to you, how you display data. So if you're going into like a business degree or some sort analytics, something like that where you make a ton of money, this is basically what you do most of your life. You just kind of show different ways of displaying data, and with charts, whatnot. Okay. So let's talk about like the major types of relations, the things that we need to know in this class for sure. Number one, obviously, we need to know what coordinates are. We kind of discussed those on Friday. Are you comfortable with the coordinates, like ordered pairs, 1, 2, and how to graph that type of stuff? Okay. So that's one type. It's just putting data into very clear, specific sets. Okay. The second type is a graph. And, that's also what we did Friday. Can you graph those? Can you put those on this type of chart and plot the points? Okay, because it will give you a general trend of data. You can kind of see that. Hopefully it's not a scatter plot where there's just random dots everywhere. Hopefully you see that there is a trend. Like the more products you sell, the more products you make. That type of thing. It's not going down. All right. Now the next type is a little bit different, right? The third type is one that we need to discuss. I think you get them in like Algebra 1, but you probably don't see it until now, or maybe of you got lucky and you saw it in Algebra 2. It's called a mapping. Mapping. It's a very specific way of showing relationships of data. They usually use mappings for like when they're displaying data for the national elections, which are coming up. Okay? They use mappings to show like general trends in data, that type of thing. All right. So mapping. The fourth one, which you also experienced on Friday, was a table. Tables look really close to a mapping in sort, but there's subtle differences. And then the last one is something that we won't see maybe for a couple sections. It's when we start getting into the inverse operations and how we find inverses or functions. And that's what we look at right here on number 5 is inverse coordinates. So these are coordinates only. The inverse function itself. Alright, so my goal today is to show you kind of like, if I were to give you a set of data, could we put it into each of these? Does that make sense? Like take one set of data and put it into every form that you're comfortable with. Once we're through there, then what we'll talk about is functionality. Is it a function? Is it not? What makes it a function? That type of thing. And then talk about domain arrangement. And that'll lead us into our implementation. Okay, so let's start with coordinates, right? Let's come up with just, let's go like maybe 5 or 6 different numbers, very easy numbers. So we'll go something like negative 5 comma 4, negative 4 comma 3, negative 3 comma 2, negative 2 comma 1, negative 1 comma 0, 0 comma 2. So this is my function of some sort, and I'll explain what makes it a Do we agree those are all coordinates? Easy. Most people are very comfortable with coordinates. Now we'll plot these, and you already said like they don't look random, because there is kind of there's a pattern to them. So negative 5, comma 4. So we're in the second quadrant there. Negative 4, comma 3. Negative 3, comma 2. Negative 2, comma 1. Negative 1, 0. 0, comma 2. 1, comma 4. 2, comma 6. And there's my data. And if this, let's say there was many more, then you could draw the line and stuff. But right now I don't have lines because these are just kind of scattered dots. So what I have so far is I have coordinates and graphs kind of put together. Does that make sense? Now, what makes this a function so far is that for every x number, you agree that there's one y number getting spit out for every x. Now, don't get me wrong. I know that some of the numbers repeated. Like, for instance, when I plugged in the negative 3, what was the answer coming out of it? 2. And when I plugged in 0, it also spit out 2. That is not a problem. It's not a problem. Okay? Because for every x, you get one answer coming out. And, it wasn't this situation where I had 1, comma 4, 2, comma 6, and then the next coordinate was 2, comma 7. Now we would have a problem. So 2, comma 7, it had two different answers for the y's, for the same digit, for the number 2. Your calculator will not do that. Your calculator won't choose to display two different answers to you. Maybe the more modern calculators can, like the brand newest ones, maybe like Jackie's, maybe yours can. You have that like crazy high-end one now. But most calculators will, if it cannot display both answers, it just gives you like some error. We'll say like domain or range error. Because the problem is, it's not a function. It fails to be a function. Functions, for every x number, there's one output coming out of it. That's what makes it a function. So the simple test that you do for graphs is we call it the vertical line test. You guys remember hearing about that in algebra 2? Yeah. Okay. So vertical line test, it's like it's the easiest, most common sense way to test. You draw a straight line going down, like this, like you do with an imaginary line in your head. Did it hit two coordinates? Now in this case, no, it did not. So it is a function. That's the idea. Because what we're testing is like for every x number, it only has one answer. So like if I gave you that example, there was going to be a problem right here. So I don't want that. So that's what makes it a function around. So that's why I prefer to have a graph to test functionality. All right, now mapping. Very, very different. A mapping looks like this. This is a mapping. You're going to separate the domain and range. Domain numbers are over here. Range numbers are over here. Now, if you don't know what domain is, down here, these are x numbers. So how a mapping works, it's a big circle, kind of looks like two lungs side by side, and it's going to be connected. There's boosters that connect. So what I need is all the x numbers in order least to greatest. No repeating numbers. That's how mappings work. So what's least to greatest for my x's? Okay, good. So the x numbers are, I just gave you that because I want to make it easy. Now, for the range, I need the y numbers least to greatest. No repeatings. So, 0, 1, 2, 3, 4, and 6. 6. No repeating numbers. Make sense so far? Now all we do is for mapping, you draw arrows. So the number 5, negative 5, what was that associated with?
We need to call it a day. It's an omen. Yes.
So what was negative 5 paired up with? Okay, so negative 5 was paired up with the number 4. So you draw an arrow. Notice the tail, the end point, it's like gray really, but the end point's at 5, the arrow is pointing at 4. Very distinct. It's not curved, it's straight gray. What was negative 4 paired up with? 3. Negative 3. Negative 2. Negative 1, 0. 0, 2. 1, 4. And 2, 6. So, pretty random. Like, if I was saying. You know, from a mapping perspective, it looks like just random arrows. It really does. When you look at the graph, it makes more sense. Sometimes the mapping, when you see it, it makes more sense because most of the data is going to one specific number. It's like it shows you a trend. So for like national elections, what they do is they just show you two numbers, like two candidates, and they just show where the percents are going. Like 50% of the people are voting this way, 60% of the people are voting this way. What the numbers make sense. But does that make sense? Like how they're going one direction. They just show you the two numbers. They don't even show you the mapping. They just show you where everyone's voting. That's all they do.
Would it be terrible in this like every rule to just write across the next pair, like rectangle side and
No, the idea is that these have to be least to greatest. The mapping is very specific. Least to greatest, no repeating, arrows pointing towards the arrows. Yeah. So what you're thinking of is an actual table. Table is where you go least to greatest for x's, and then the pair is just straight across. So that's the difference. This would be a table. Table will look like this. You have x numbers, you have y numbers. X numbers are -5, -4, -3, -2, -1, 0, 1, 2. And if there's any repeating numbers for the x's, you just put those where they need to be. You would actually put repeating numbers. And for the y's, now you just put the answer straight across. So what was the answer that I went with? -5. 4, -4 went with 3. This is 2. This is 1, 0. Then it goes 2, 4, 6. Okay. So it looks like coordinates. It really does. The problem is I wrote the coordinates equal. Like usually the coordinates are random. It's whatever data you collected, and you're not. Like most people when they collect data, they don't keep it really organized right away. They just get all the data on paper, and then what you do is later on you use the table to organize it, least to greatest. That way, so if you have the random data, you class it to a table, then you can use the table to make the graph. Does that make sense now, like why you do it? And then obviously the mapping is to see where like general trends in data are. Now, for me personally, to check functionality, I like the vertical line test. You can check for functionality using a mapping, because how a mapping would fail. So if I had this 2, 6 or 2, 7 like I had earlier, this would show you where it fails to be a function because now the number 2 would actually branch off and go to a second number, and that would be a fail. Because you never want one x number going to 2 different y values. Does that make sense? So I don't mind if a bunch of these numbers go to the same number. That's fine. That's okay. But it's this idea that number 2 cannot be going to 2 different answers. Your calculator cannot handle that. It'd be like the situation where you're looking at a voting ballot and somebody votes for both candidates. You can't do that. You got to pick one or the other. That's a failing functionality. They check that. And individual numbers, or see if they're re-voting twice. That's just a simple check that they look for. Okay? So that without on a mapping, this would fail functionality. And now obviously on a table, it'd be really clear. It'd be obvious on a table that you'd see that this would happen. There's 2 x numbers and they're going to 2 different y values. If it was the same number, maybe like you did some data and you had the same number, that's still a function. That's fine, it's the same number. But when it goes to 2 different ones, now it fails to be a function. Okay, well, we're good with all the different types of relations. The only one we haven't talked about is inverse. Inverse is where you flip coordinates around. So an inverse coordinate would be, the first one would be 4, -5. 4, -5. -3, -4. Do you see how inverses work? And you just keep going. These are inverse coordinates. Now, you're probably wondering, why would you do an inverse? That seems silly. Why would you just flip the numbers around? What analytic person would do, somebody in like a business degree, they would look at what the outputs are and what would be the input needed. So they look at, like, okay, it's not just going with data where you're collecting data like, okay, this is how many products we have, this is what we sold, that type of thing. It would be the other direction. How many do we need to sell to justify having that much product? Or like maybe they're looking at, instead of like looking at what we sold and what our profits are, I want to know when will we hit this profit number? When are we going to hit 10,000 for a profit for the first time? And they'll look back and see, okay, this is what we need to make sure that happens. We need this much profit. They look at how much did you have on So it's going backwards and forwards. So that's why you actually need the original coordinates and your inverses. They can map out stuff. It's the same idea as like when you guys are factoring. When you guys are factoring things apart. You guys were looking for which x values make the thing equal 0, right? That's what factoring was. And that you're doing inverses. That's what you're doing. You're breaking things up. You're going backwards through the order of operations to solve. You have your y value. I want the x numbers that make it work. That's everything. Okay. Questions, comments, concerns? Okay. Now, last topic today, we've got to talk about demand range. The biggest topics today. We're only going to do it 4 graphs today. Okay, now for plots here, for just single coordinate plots, domain is pretty easy. You just list up all the x numbers that you see there, and you separate them by commas. The problem is, I don't want that. What I want is interval notation. So that's the main thing I want to discuss right now, and we'll be done after the years. So, I want to talk about how to find domain range using interval notation. There's other types of notations, set notation, roster method, that kind of thing. Interval notation is where you use parentheses or brackets, and you use unions to make sets, to make like the list of numbers in a particular order. Okay, now for this particular graph, I probably would not do this situation. It'd be a lot longer using intervals. What I use interval notation for is very flowing graphs, continuous graphs, graphs that have lines that are connected, that are flowing, because they're easy numbers to pick out. Okay, when they're scattered plots like this, what I would do personally is I would just do a roster method. I would do a roster method in this particular case for a domain. Because there was only select numbers I plugged in, correct? I plugged in what? 7, 8 numbers? There's 5, 3, yeah, there's 8 different x values for a domain here. So your domain in this case is what are your x numbers? Well, my x numbers in my case, x is equal to, and I would just do the roster method. The x values were -5, -4, -3, -2, -1, 0, 1, and 2. That'd be the roster method, putting least to greatest, just my x numbers. Now, what were my y values? What were my y values coming out of that thing? What was my smallest y value going this way? Looking at numbers like this. Yeah, 0 is my smallest y value. What was the next number? 1, 2s. I had a couple of 2s, right? So 2s. I had 3s. I had 4s. And I had 5s. Or sorry, 6s. Yeah, 6. All right, now for a roster method for a domain, you wouldn't need to put repeatings. Okay, I'm just showing you where all those numbers come from. Okay, so I'm looking at the range of whatever your y value is spitting out of that thing. So I look horizontally, not vertically. Vertically, I'm looking at x numbers like this, or my x numbers like that. Y values are these numbers on the y-axis. Okay, but do you agree like this makes sense during domain range? When it's like when they're all broken up and there's just a bunch of individual dots, roster method makes way more sense. Least to greatest, separate all the different entries with commas. Different entries, not repeating. Right? Now, if it was a flowing graph, I would not do this. Because you'd have to list every combination. Well, there's an infinite. You have to list decimals and other things. So I wouldn't do that. So I'm going to do interval notation. So let me show you how that works. And there's 2 types of intervals. Okay? There's set notation and there's interval notation. So let's do a graph where we have domain range. This will be our first example today. Okay, so domain. I'm going to do it with interval notation first. Do you agree that this graph is very flowing? It's not going forever, right? It definitely has starting and stopping points. So let's talk about domain on this particular case. We'll look at more of these tomorrow. This is just going to be our first and What was the smallest x number that I had? What does that work? Negative 7. Okay.
Sorry.
Now, do you agree? Yeah, 1, 2, 3, 4, 5, 6, 7. All right, so that's my smallest. Now, did I include it?
No, you didn't.
No, it's an open circle, right? So, when you do domain, we're looking at x numbers, right? X values. All right, now for integral notation, if it's not included, that's when we use parentheses. Use parentheses if it's not included. Use brackets if it is. Okay? Make sense? So, we're not including the number negative 7. That's my smallest x value. Now, we went up. We went up for until, there's a break in the graph. There's no breaks until here. There's a break. What number is that? 1, 2, 3, 4, 5, 6, 7, 8, right? There's a break right there. So I write that number down. Now, do I include the 8? No, because it was an open circle. So I use the parentheses. That's the domain in integral notation. Because is there any arrows going anywhere else? No. If there was a break in the graph and I continued, say I continued like this, now since there's a break in the graph, you do a union, and you'd start, and you'd go on. So, okay, so it stopped at 8, but then it suddenly picked up at, what is that, 9? It suddenly picked up at 9, and it actually included 9. And then it went towards positive infinity. I mean, it just went forever on the x-axis, and it has an arrow, so it doesn't stop, so it goes towards positive infinity. And positive infinity is not a number, so you don't include it. It's just a direction. You see how this works now? That's domains, your x numbers. Don't look at the y numbers, look at your x's. I know somebody's going to look and they go, oh, that's number 2. It's the number 9 on the x. That's domain. Okay, does this make sense now? If there was a break, no, we continue over here. We just have something up here with the union. But this is domain. Now let's talk about range. Range are now the y values. Y values, least to greatest. So, what's my lowest y number? Negative 4. That's my lowest y number. What's my upper value? We learned this little guy. 6. 1, 2, 3, 4, 5, 6. Positive 6. That's your range. Notice, I don't care about these little open dots. I don't care about those. I just look at what's my lowest, what's my highest. There were no breaks in the graph in between. It was pretty flowing. Okay? If it had a situation where the graph went higher later, then I'd have to worry about where it picked up from here and went on, right? But it doesn't look like it. So it looks like my lowest number was negative 4, and I'm including it, because there was an actual solid out there, and my upper number was positive 6, and I'm including that. All right. So for this original graph, this is my domain range for intervals. Does that make sense? Now, if it suddenly went higher, let's say we had that weird, stupid little thing back here, and it did this earlier. Now my domain has changed. It went from negative 4, up, and it doesn't look like it stops, because, this took over. This took over at some point. So it went from 6, and it kept going. So this would be your number. It looks like it's going towards positive infinity, and I'm not including it. The only time you need to use unions is if there was a break between 6 and whatever numbers are up here. So maybe this graph did something like this. It picked up at 10 and went up. Well, now there's a break in the graph. It went from negative 4 to 6. It went from negative 4 to positive 6. It took a break. We did a union, and we picked up at 10, and we went to positive infinity. You see how you can use the unions to make breaks in the graph? But again, it's just y numbers. That's all I'm looking at. I'm not looking at x values. Okay, we good today? Okay, we're going to end there. We'll continue with this stuff tomorrow. I know this is tough. I know it is. This is like your first kind of real days using this, looking at it. Some of you can pick this up pretty quick. I know that. Some of you will struggle with this for a while until you realize that there's just a simple process for how you use it. Okay. We'll pick up tomorrow. We'll definitely look at some more options with this, like max and mins and all that good stuff. Okay, you have the rest of the time where you can work. 9. When are you going to take your test?
axles and axes are out, set out. And as soon as they're out, I put it dry and I just take off and I'm shooting rocks.
Oh, okay.
I'm shooting rocks at nag.
The board.
It was pretty chill.
30.
Okay, so these charts, this is your X numbers, these are your Y numbers. Now this is the lowest X number, this is the biggest X number, and something by 1. So is there any graph down here, A, B, or C, so it looks like it starts at -5 and goes up to 5 on the X axis.
Exactly. You guys keeping when I was working? Then after that, Bailey Golfin came in, and we had a temporary master.
This is 29.
Everyone else was Steve, and he checked for White House. Yeah.
Yeah, it was awesome.
He was so he gave Bailey an order. He just says, "Chow," and walked away. And you can hear Bailey screaming the entire way through the driver. And then later that night, Jack and Seth and Alex and Gerger and those 2 souls and
Yeah.
You already know.
He came in and he let us go behind the counter.
yeah. And Jack was like, "Can I go back?" And he's like, "Sure, why not?" Jack's like, "Are you for real?" He goes, "Yeah." So they're all back there and
And Durr spilled like 12 on you or something.
no, well, okay, Durr was talking to me and I was talking shit and it got all on my phone.
Which
I was so mad.
Why one and X? Why two
When
and
you entire cannon. Because that's when you entire cannon. Yeah. His name is Felix. He had long black hair. He looked like a Mexican.
Exactly.
Maybe parties. No, parties. Sorry. Parties. I don't think so. All I know is that where he works, he works with people who Jack, and his work with me, he goes, like, you're actually not doing work, he goes, I do every day. He goes, oh, I always have to do films with my dog, and it's still, I'm like, dude, that's why you need to come over, you work with us. Your job is 10 times easier, and we have chill managers.
Yeah, just those ones that go by graph. Just put the dots up there.
Oh, yeah.
I
He was like,
just
just
have
out of
to
his, he was like,
create
I want to do something.
the one that like goes
Goes up
up.
to like 29 or something.
Yeah.
Yeah, just
Just
put a
like
dot
if
above
I-
and just say what the coordinate was. You don't need to like set a graph. Some people like they change their graph like they jump.
Oh,
like,
yes.
That's what I did.
We were
Yeah.
talking about,
You're fine.
he's like, that's just fabulous.
I mean, it looks a little
Yes,
strange.
that's
Most of the
we were like,
dots will
blood
be on the
cancer,
graph
super
except for like that
against
one.
leukemia or something like
So.
that. And, yep. That's who it was.
Are these in the back of the book?
And then he likes blasting.
Yeah, some of them are. Jackie, you guys only went 2 games with Newman, correct?
What?
You guys only went 2 games with Newman. The video was quick, so you guys must have made short work of that. It was like a 20-minute game. Because it always throws me off because I look at numbers. I'm usually pretty good with like when a game starts, I know it's going to take, lose my camera always records in blocks of 3 minutes. So that's easier to flow. So I was like, okay, 12 is a match. Yours against Newman.
Come on with me.
Here we go.
And it threw me off. I'm like, did I write it? Did I like? Did we not get it?
Oh, that.
It was just quick. Or you guys struggled a little bit.
The first game.
You guys came out that high against Central Spring.
Central Springs lost to Westport too.
Yeah. They're ranked top 10 in the state.
They must have not even done that.
The problem is I think they play different competition. Plus, I think they're too good.
It's 24 times. Let's see, you start on this 100 something. 140 a month. You can make 140 a month. Jake spends on gas. on 236.
Well, I got.
What? Me? I got you.
What?
You just write way up there and draw a dot. You don't have to like draw on top of the page. Sure. Yes, sir. So for number 44 there, you have to write like the x-intercepts, and there's 2 x-intercepts. Is it right?
Which number is that?
44.
Yeah.
That's right, negative
Don't
1.
write the action steps, just, you know, one and negative.
Oh.
Oh man.
The red horse ones. The red horse. I was gonna get them, but in my size, they're all like 250 and more. So I'm like, oh man, that'd be kind of bad.
That'll show me. I don't think I've ever had too much play except for like
Hold on. Order them off Foot Locker.
Drag it on.
Order them off Foot Locker. You put on some more.
Why didn't you just
Ah,
dress
just-
up more?
Yeah. You'll get a little bit of beat up, buddy, that.
Pension, we'll probably give you
Does that feel,
What?
100% business all here? Yes. That's good.
You didn't get that?
There's that, there's another.
maybe the 100% business, like, I just have 6 minutes.
We're talking a good.
We're talking this big
20%.
20%.
Durgar doesn't have
2%
20%.
for OSG.
Yep.
There's-
Okay, where's the retail?
Oh,
And he slaps my hand and goes, ow. And I go, Durgar, how did that hurt you? And he goes, because you have bones. And I go, Durgar, you have
Doing
bones.
his best to teach
somebody
somebody.
friendly.
He gives me his best, I give mine.
So Durgar can join the Skulls Crew.
You know that's banned.
What is?
Pension, everyone.
Oh, are you bottle flipping,
Tyler
Tyler?
wants to do
No,
pension.
wow.
Tyler wants to do pension. Tyler, go.
Lord, I like how serious you got about it.
Please.
Hate it.
It's 'cause you're not good at it.
Punch yourself in the face.
Like,
See what attention you do for your class.
Jack,
No, but
Jack,
the-
today during
the-
math,
John, what?
Jack, today during survey thing, Sherwood had a gum wrapper. He was flipping it during the thing. I'm like, Sherwood, oh my god.
No, the feeling, Dick, are you got your phone yet?
Yeah.
What did you get?
Same.
I remember last night.
What did you get?
Johnny and I got these very much.
The Great Kobe?
Yeah, those. Good. John.
Homework.
Everyone's getting Kobe's, I'll tell you that much.
I just want everybody to know that I started this.
What size are you?
I started this whole thing.
I don't know, it's kind of up in the air. You don't know what size I mean, how
Seriously, right now I got a pair of tennis.
I wasn't running at the meetings.
Yeah,
but I can wear this.
Practice.
I can wear tennis pants. There's 10 right there. And, are those dope? I know. I was gonna get those. Sending them all out. You're the sun.
They don't need me.
Jordan, you need to get some.
If anything, you're breaking them down.
Honestly, I can show you the oldest walk in where they got 5, 6 people. And it doesn't tell.
These things are all there.
Oh, this one actually does.
Check this out, Jack.
Those are dope.
Jack Wilson, the best name ever was. I think my doggo has autism. And it's
What?
Greg, you didn't think you got
Those tomorrow.
He's got autism all day.
I'm thinking Landon. He's like, no, that kid.
Yeah, I've seen that.
It was pretty neat. That's pretty neat.
That's pretty neat.
How neat is that? It's pretty neat.
I'm just gonna pack some deep.
Okay, Spencer.
You see that? There's an aspen tree. You can tell that's an aspen by the way it is.
You can tell that's an aspen tree by the way it is.
Spencer.
How neat is
Hey,
that?
somebody's just hated it right there.
I know, I'm throwing it away. It's like on the floor.
You know what it is?
No. If I did, I'd throw it at you.
That's the best thing ever, too. Guys, I think my dog.
Wait, we have a new scene arrangement?